Hello dear students, welcome to physics class. Today in this video lecture, we are going to learn about electric field strength, force on charged particle in electric field due to point charge, and types of distribution of charges. So let us start with the electric field. What is electric field? Electric field is defined as the space around a charge in which its influence can be felt by any other charged particle. So to understand this, we have two kind of charge. First one is positive Q, that is your source charge, which will produce a field, and the size of source charge is greater than the test charge. This one is your test charge. We will place this test charge in the field of Q charge. So what will happen here? You have a Q charge, and around Q charge there will be electric field, and the electric field lines we will represent outward side for positive Q charge. So this is the space around a source charge. If we place a test charge is very small, that much small. Q tends to 0 means this charge is very small and it is almost near to 0. I will explain you why we are taking this test charge is very small. So now we will place this test Q naught charge in the field of positive Q charge. So what will happen? This Q naught charge will experience a force. It will experience a force due to electric field lines. So this Q naught charge will experience force due to the electric field. So electric field is the property of a charge due to which if you place any second charge inside that field, so that charge will also experience a force. So this Q naught charge is experience a force. So this is electric field. Now we will discuss next topic, the properties of test charge. Source charge is a bigger charge which is producing the field, and now we will study what is test charge. We will always take test charge as a positive charge. The second thing is test charge is so small that it does not create any electric field of its own. You have a positive Q, that is your source charge, and the amount of source charge is always greater than test charge. Why test charge is so small? Test charge is always very small, near to almost 0, so that it cannot disturb the field line of source charge. If both are bigger charges, if Q naught is having greater value or larger value, so this charge will also create its own field lines, and what will happen? It will try to disturb the field lines of first charge, and we cannot find the exact value of force. We cannot find the strength of this field that is produced by positive Q charge. So that's why always we used to take Q naught approximate near to 0. So that's why Q naught is limit. Q naught tends to 0. It means test charge is very small, so that it cannot disturb the electric field produced by the first charge. Otherwise we will not able to measure the strength of force, right? So always take test charge positive, and the value of the test charge is very small as compared to the source charge. The next thing is electric field strength, or you can say intensity of electric field. The other name is intensity of, or you can say intensity of electric field. So how will you define it? Intensity of electric field. So the force experienced by a unit positive charge placed at that point. So according to the electric field, if you have a force, if you have a charge, suppose you have electric field lines and you will place the charge inside the electric field line. So this charge will experience force due to this electric field. So E is equal to F by Q. So this is your electric field relation with force and the charge, and in this case your charge, this is your test charge. So limit Q tends to 0 you can write. This charge is test charge. When you placed a test charge Q naught inside the electric field, it will experience a force F. And what is the SI unit of this? Newton per coulomb. And the dimension formula you can write for Newton means force ml T minus 2, and for coulomb it is per coulomb. So even you can write per coulomb, otherwise you can convert C is equal to 80, because we know Q is equal to I is current, T is your time. So you can replace this one with M L T minus 2, and what is your C? C, because this is in inverse, so we will write in inverse. So this is the dimension formula for electric field strength. Now next we will find electric field. Before that we will find force on a charged particle places in electric field. So what will the direction of force when you will placed a test charge inside the electric field or a simple charge inside the electric field? So let's see. You can see here we have electric field lines, that is E is the electric field lines, and this is a uniform field. So first of all we will place this number 1 Q naught charge inside the electric field. So what will the direction of the force? So when we placed a positive charge inside the field, the force experienced by positive charge is always towards the direction of the field. So for first charge, what is the force direction? Along E. So both having the same direction. What about minus Q naught charge? So if you have a negative charge, so direction will always opposite. Okay, so the force direction is opposite. So you can note these two important points. For positive charge, force acting in the direction of electric field, this thing, and for negative charge, force acting in the opposite direction of electric field. So these two things will help to solve the numerical problem based on that concept. So next we will discuss now electric field due to an isolated point charge. Now we want to find electric field at any point. Okay, so we will consider again a test charge. Let us consider positive Q is a test charge, and this charge is at O point. Let us, this point is O, and we want to find electric field line at this point, P point. We want to find electric field value at P point. So how will you find the value? We will place a test charge. This is your test charge. We will place a test charge at point P, and we will test the strength of this source charge. This is your source charge. So how much field it will produce at P point, that thing we have to find. So first of all we know what is Coulomb's law. If you have two charges, so electrostatic force of attraction will be there. So first of all we will find the electrostatic force of attraction between the two charge particle. So what will be it? 1 by 4 pi epsilon naught. What is the charge? Q, capital Q, and Q naught. And what is the distance between the two? The distance is your R naught. So this is your Coulomb's law, and this one is in the vector form. So we will write here unit vector. Unit vector represent the direction. And what will the direction of force in this case? Because Q naught is test charge and this one is a positive Q charge, so direction is along the field lines. So this side will be the direction of force. Now next one is we want to find electric field lines. So electric field line, we know E is equal to F by Q naught. From the electric field strength, from the definition of electric field lines, you can see here we already derived this formula. So now we are using this formula to find the electric field due to an isolated point charge. F is your vector quantity. So now substitute the value. What will you get? 1 by 4 pi epsilon naught Q naught R naught square and R naught cap, and F is divided by Q naught. So divide by Q naught. Q naught will cancel, and you will left with E is equal to Q by 4 pi epsilon naught R naught square, and R naught cap, it represents the direction of the electric field lines. So this is the expression for electric field due to an isolated point charge. But this formula is valid only. This is valid for point charge only. This formula is valid for point charges only. When you have a point charge, you will use this formula. So now when you have continuous distribution of charge, means you have a charge which is in continuous, so we will use the different formula. We cannot apply the same formula for this. Now next we will discuss types of charge distribution. So one by one we will discuss types of distribution of charges. First one is linear charge distribution, second one is surface charge distribution, and third one is volume charge distribution. Okay, so now let's start. We will discuss first one is linear charge distribution. So let us consider we have a linear body. In linear body we know it's a straight line, and let us suppose there is a uniform charge distribution on it, or you can draw the positive charge on it. This body having a positive charge, and let the value of charge is Q. Now we will choose a small area element. Let us this element. We'll choose a small element of this rod, and let the charge on that element is dq, and the length of this green portion is, let us suppose, that is dl. So what is linear charge distribution? We can write, we will represent linear charge distribution by lambda symbol. It will represent by lambda. So lambda, you can write lambda is the charge per unit length, or you can even write dq is equal to lambda dl. Similarly, you have a one square, and now we will write the surface charge distribution. So let us consider one surface is there, that is your square, and now give some positive charge to this square. Let us consider the total charge on the square is q. Now consider a very small portion of this square. Let us consider this portion. Everywhere positive charge is there, and let us consider the area of that small portion of the square is dA. Surface, you can say small surface area is we took, and the area of that small square is dA. And the next one is, what is the charge on that? Let us consider charge is dq. So how will you represent surface charge density? It is represented by sigma, and what will be it? Charge per unit area, charge by area. So you can write dq is equal to sigma dA. This is the formula for surface charge density in terms of charge. Similarly, volume charge distribution, so in this case you will consider a spherical body or a cubical, even you can consider a cube. Here I have taken a spherical body. So let us consider again, let the charge on the sphere is q, charge is q, volume is b. Here you can consider total area A, and here the length of the rod is L. So what we will do, again we will choose a small portion of that sphere, and let us consider the volume of this one is small portion is there, so let the volume is dB. So it is what is the charge? dq. So now we will calculate the volume charge density. So density will be represented by volume charge distribution, we will represent by rho, by this symbol rho. And what will be that? Charge by volume. So dq is equal to rho dV. So this one, the three charge distribution. These are the types of charge distribution. So these will help to find the electric field for continuous charge distribution. So remember all the three formulas to solve the further derivations. So for today it is enough. Next lecture we will meet very soon. Thank you.